Hello everyone, Mr. Cruze here with another review for you. This time, the 9.1 to 9.2 quiz review. This is all about t-tests around the mean, when we have one sample and two samples, okay? So I'm going to do two examples. Your review actually has three problems, and that is due tomorrow. But I'm going to do the first two problems, because one of them is one sample, and the other is two samples. So let's get into it. The skid properties of a current snow tire have been tested, and a mean skid distance of 154 feet has been established for standardized conditions. So they've established this. That's going to be mu. A new, more expensive tire is developed. Tests on a sample of 17 new tires yield a mean skid distance of 148 feet with a standard deviation of 12 feet. Because of the cost involved, new tires will be purchased only if it can be shown at the 5% significance level with a skid a shorter distance than the current tires. Based on the sample information, will new tires be purchased? So, let's run our hypothesis test. Step one is to state your hypotheses, right? This is clearly one sample. They ran a sample of 17 new tires. So we're going to be comparing mu to an actual number. And that number is the 154 feet that I mentioned earlier. Okay. Now, I'm trying to test that they skid a shorter distance. The new tires skid a shorter distance than what they currently do. So that means it's going to be less. I want them to be less than 154 feet. Obviously, that means the opposite. That's going to be greater than or equal to. Okay. Hopefully, we're good so far. Step two is state your level of significance, which in this case is 0.05. Nobody argues with 0.05. Step three, as I said, this is a one sample mean t-test. Please make sure you have all of that there. One sample mean t. Otherwise, it will be wrong. Step four. Step four, we're going to basically decide what's going on. This is clearly one-tailed. It is one-tailed because we're doing less than, right? It's pointing in one direction. It's pointing to the left. This is technically called left-tailed, but it's one-tailed. And as usual, we're going to reject as long as our p-value that we get is less than or equal to alpha, which in this case is 0.05. All right? Step five. We're going to calculate that t-score. For one sample, the formula is x bar minus mu over s over the square root of n. Okay? So in this case, x bar, well, that's our sample mean, which we calculated to be 148 feet, minus what we originally claimed was mu was 154, over the standard deviation, the sample standard deviation, which is 12, over the square root of however many we sampled, which in this case is 17. Okay? Now we are going to go to our handy-dandy calculator, which is ready to go for us. Make sure you type parentheses in the correct spot. So I need parentheses around the top, because I want to subtract in the numerator before I do any division. Divide by, on the bottom as well, make sure you have parentheses, because you want to take care of the whole denominator first. So 12 divided by the square root of 17. Okay, please make sure you have those parentheses. You should get a t-score of negative 2.062, it looks like. Negative 2.062. Remember, as far as we're concerned, we expected a negative t-value, so we're going to ignore the negative, treat it as if it were positive. We're going to go ahead and go to our table after I figure out what the degrees of freedom is. Make sure you include the degrees of freedom, since this is a t-test. The degrees of freedom will always be, for these, the number in your sample minus the number of samples. So it'll be 17 in our sample minus one sample. So our degrees of freedom is 16. So I'm going to go to my t-table here. I'm going to go to row 16, which is right here, and I'm going to look for the two values that surround negative 2.062. So negative 2.062. It looks to be between 1.746 and 2.120, which means my p-value is between these p-values, which is 0.025 and 0.05. 0.025 and 0.05. Now, I don't exactly know what the real p-value is. I'd have to use technology to get it, but I know it's somewhere between 0.025 and 0.05. It's one-tailed, so I don't have to double anything. But anything here between 2.5% and 5% is still going to be less than 0.05, which means I'm going to reject. I reject the null hypothesis. We can conclude, make sure if you reject that you can conclude whatever the alternate hypothesis is. We can conclude that the new tires skid less. New tires skid less than the current tires, or they skid a shorter distance. So, should new tires be bought? Yes, new tires should be purchased. Fantastic. Okay, that's a one sample. One sample is pretty easy. It's just like the one sample Z, basically. The hardest part really is just looking things up on the table and making sure you have correct parentheses. Let's go to the two sample. Okay, the tensile strength in newtons per square millimeter of a metal is a measure of its ability to resist tearing when it's pulled lengthwise. Using a new experimental type of treatment, a sample of 10 bars with a mean of 340.3 was produced with a standard deviation of 22.301. Using the old method with a sample of 12 bars had a mean of 389.917 with a standard deviation of 15.090. At the 1% significance level, does the new method make a difference in the tensile strength of the new bars? Okay, so step one. We're testing to see if there is a difference in the tensile strength. Is there a difference between the new method and the old method? Not does the new method make it better or worse, is there a difference? Okay, so we're going to compare the new mean to the old mean. Okay, our initial assumption is they should be the same. They shouldn't create that much of a difference, but we're testing the claim that there is actually a difference at the 1% significance level. Okay. Step 3, this is a 2 sample, as indicated, 2 sample mean T, as indicated by the fact that they basically gave us 2 sample means and 2 sample standard deviations. That'll be your clue that's 2 sampled. This is also a two-tailed, not to be confused with 2 sample, but it's two-tailed because of this guy right here, the not equal to sign. Okay, we don't know which direction to look. We don't know if it's to the left or to the right, so we just say it's on both sides. We will still reject as long as P is less than or equal to 0.01. That part will not change. All right, here's the part that will change. Step 5. When you do a 2 sample mean T test, you have to create what's called the pooled standard deviation. Okay. The formula for this is N1 minus 1 times S1 squared plus N2 minus 1 times S2 squared all over N1 plus N2 minus 2. Okay? Awful formula, I know, but that's why we have calculators. They'll do all the hard work for us. Okay, so how many were in our first sample? Well, our first sample written was the new, so we're going to do new first. Okay, so let's see. There were 10 in the new sample. So 10 minus 1 will be 9. Oops, I erased my square root there. 9 times the standard deviation squared for that first guy. So the standard deviation was 22.301 squared. Okay, maybe I should give myself a little more room there. 22.301. 9 times 22.301. How many are in our second sample? The old sample. There were 12 bars, so 12 minus 1 would be 11. Times whatever that second standard deviation is squared, which is 15.090 squared, over the bottom part, which will be 10 minus 12, or 10 plus 12 minus 2. Okay. So, here's where I'm going to go to my handy-dandy calculator. If you put parentheses, because remember, your calculator will put a parenthesis there automatically. If you put a parenthesis there, and there, and then there, and there, you should do just fine. Okay, it shouldn't create any problems. So again, let's go to our handy-dandy calculator, which should turn on for us. Alright, there we are. Big square root. Notice that it puts parentheses there, so I'm going to put a second parenthesis to make sure I capture the top. And then just type it as is. 9 times 22.301 squared plus 11 times, and notice I'm not even putting any extra parentheses inside the top. I'm just doing as is. Okay, so there's the entire top. Notice I've surrounded it in parentheses, divided by the bottom as well in parentheses. 10 plus 12 minus 2, double parentheses, and if you hit enter, you get a pooled standard deviation of 18.683. 18.683. Okay, it should make sense, by the way, that this standard deviation is between these two numbers somewhere. Okay, if you get something like 2, in this case, that would be way wrong. All right, so the formula to actually calculate the t value for this, for a 2 sample, is x bar 1 minus x bar 2 over your pooled standard deviation times the square root of 1 over n1 plus 1 over n2. So let's go ahead and figure this out. Let's see, what was our new sample mean? It was 340.3 minus the old one, which is 389.917, over our pooled standard deviation, 18.683, times the square root of 1 over, our first sample was 10, our second sample was 12. Okay, so again, here's where we get into a little bit of trouble with parentheses. Make sure you have parentheses in the appropriate spots. Okay, so again, let's go to our handy dandy calculator. Top first, 340.3 minus 389.917 divided by, parentheses, 18.683. And notice I'm not even going to type a times here. I'm just going to go ahead and type the square root. 1 over 10 plus 1 over 12. And you can put double parentheses there, and that'll be cool. We get a t-score of negative 6.202. Okay. We need our degrees of freedom as well before we go to the table. Degrees of freedom in this case, again, total in your sample minus the number of samples. It's basically this part right here in the bottom of your pooled standard deviation. It's 10 plus 12 minus 2. So it'll be 20. Our degrees of freedom will be 20. Okay. So we're going to go to our table and look for values that would surround that. So again, ignoring any negatives. Okay, and I'm scrolling. I see the biggest number on here is 3.850, which means I am way far off to the right, which means my p-value is going to be way smaller than 0.0005. Okay, so my p is definitely less than 0.0005. It's probably almost 0. And guess what? That is still... oh, I forgot. I need to double this because this is two-tailed, right? So I need to double this. So really my p-value is smaller than 0.001, but guess what? It doesn't matter because that's still smaller than 0.01. Whatever that is, it's still smaller than 1%, which means we're going to reject the null, and we can conclude, okay, we can conclude that the new method makes a difference in the tensile strength of the steel bars. Okay. Again, just a couple reminders. If you do not reject, you cannot conclude that whatever the alternate is claiming. Okay? So please be careful. Make sure you have all this work, guys, because this is the stuff I'm looking for. If you don't have this, then you'll start losing points, all right? This is really everything that you guys will need, okay? If you have any further questions, don't hesitate to tweet me or email me at Mr. Cruze Math or cruze@gws.k12.in.us. You may also feel free to stop in and see me in the morning, all right? Good luck studying, and I will see you guys later.